Hello, this is Chris Esson. In the previous video, number 62, I explained the two greatest discoveries of Nikola Tesla. First is dynamic theory of gravitation, based on the presence of an ether, filling space, a theory which is in total opposition with the hypothesis of Einstein's general relativity. And then the implementation of electrogravity, based on asymmetrical electric impulses of very high intensity interacting with the ether. In the February issue of French magazine Top Secret, you will find my article on Tesla's physics, which explains how to find, thanks to the ether, the same results as the Schwarzschild metric, solution of Einstein's equations, to explain cosmology. In video 54, I show that the ether brings simple explanations to the anomaly of the speed of stars in spiral galaxies, to the expansions of the universe, as well as to the principle of equivalence between inert mass and heavy mass. Today, thanks to the ether, and based on Léon Lecornu's physics lecture given at Polytechnique in 1916, we will continue to provide new explanations to three mysteries that are unsolved today, namely, what is mass, what is the magnetic field, and we will be able to deduce what is the strong interaction in the atomic nucleus. The hypothesis that was commonly accepted before 1905 on the theory of relativity is the presence of an ether that fills all space and serves as a medium for the transmission of electromagnetic waves. Video 62 explains that gravitation derives from the energy density of the ether, which means that the notion of potential energy and the notion of vacuum energy are in fact linked, because the former derives from the latter. Einstein's theory of relativity is a purely mathematical theory that is free of the notion of a physical ether. Although Einstein, in a speech at University of Leiden in Holland on May 5, 1920, acknowledged that the presence of an ether was ultimately necessary. However, all modern physics is built without the ether. Thus, particle physics imagines other particles, the bosons, serving as mediators of forces, like balloons, that other particles of matter, the fermions, would exchange to transfer energy. Without ether, physics is unable to explain the transmission of electromagnetic waves, and the unification of the different fields of physics remains to be accomplished. Today, each branch of physics is forced to add an energy field filling the space. Cosmology calls it dark energy, which would nevertheless have a very low density of the order of 10 power minus 9 joules per cubic meter. Quantum physics calls it zero-point energy, but the density would be phenomenal, of the order of 10 power 113 joules per cubic meter. Particle physics now introduces the Higgs field, with the famous Higgs boson, which would give its mass to particles. The question is therefore to know what is the density of this vacuum energy. Is it very weak as cosmology imagines, or on the contrary, very strong as quantum physics suggests? Let's listen to Étienne Klein, a famous French physicist, and what he says about the Higgs field.
Et puis en fait, il y a trois jeunes physiciens, qui ont de façon indépendante la même idée pendant l'été 64. Les deux premiers s'appellent François Englert et Robert Brout. Et puis de façon indépendante, un physicien écossais qui travaille tout seul, qui s'appelle Peter Higgs, écrit un papier en août 1964. Ces physiciens vont reprendre ce type d'argument pour dire peut-être que les équations du modèle standard qui disent que les particules élémentaires ont une masse nulle, ont raison. Peut-être qu'il est vrai que les particules élémentaires ont une masse nulle. Et nous qui pensons que ce n'est pas le cas, peut-être nous nous trompons depuis très longtemps sur l'interprétation de ce qu'il faut appeler la masse. Peut-être que la masse n'est pas une propriété intrinsèque des particules, mais une propriété secondaire qui résulte de leur interaction avec le vide, qui du coup n'est pas vide. Et donc ces gens vont supposer que le vide, ce qu'on appelle le vide, donc l'espace vide si vous préférez, contient en tout point de l'espace un champ un peu comme un champ de température, qui a une valeur en tout point. Et en l'occurrence, le champ en question s'appelle le champ de Higgs. On l'a appelé du nom du physicien écossais que je viens de citer, le champ de Higgs, qui est un champ scalaire. Scalaire, ça veut dire qu'il est très simple, il est décrit par un nombre scalaire, comme un champ de température. Il est partout présent dans l'espace. Et ils imaginent que les particules de masse nulle, qui sont toutes de masse nulle, comme le dit le modèle standard qui a raison, toutes les particules de masse nulle interagissent avec le champ plus ou moins fortement. Et c'est le couplage qu'elles ont avec le champ qui détermine leur masse. Nous voyons qu'elles ont une masse ou une inertie. On a l'impression que c'est elles-mêmes qui possèdent cette inertie et cette masse, alors qu'en fait, elles résultent de leur interaction. C'est comme si les particules se frottaient au vide. Alors cette image est évidemment à prendre avec des pincettes parce que ce n'est pas un frottement, c'est un couplage, comme on dit, il n'y a pas de dissipation. Mais l'idée, c'est ça, c'est que ce qu'on appelle la masse, c'est simplement une mesure du couplage que les particules ont avec le vide qui n'est pas vide puisqu'il contient un champ.
The mass of an object manifests itself when it is subjected to an acceleration or a gravitational field, which is the same thing according to the principle of equivalence between heavy mass and inert mass. And precisely, the physics course of Polytechnic explains to us in paragraph 678 that a body accelerated in a perfect fluid with an homogeneous pressure P undergoes an apparent increase of its mass, proportional to the density of the fluid, and to a coefficient specific to the shape of the body. So the Higgs field, dear to particle physicists, is nothing else than the ether pressure field, and the Higgs boson, still a vision of the mind. Let's continue to explore this physics course from Polytechnic in the chapter of fluid mechanics applied to vortices. It's important to know that physics does not know how to explain what a magnetic field line is, but the theory of electromagnetism says that the magnetic field B is due to the vortex of a certain entity A, which is called the vector potential. B equals curl A. A charged particle moving in a magnetic field is deflected perpendicularly to the magnetic field by the formula F equals Q V vector product B, effectively as if it had been drawn into a vortex. I have already explained in video 62 that the field A represents the quantum angular momentum of the ether cell. It is also known that the magnetic field line loops back on itself, possibly to infinity. Well, this is exactly what paragraph 659 explains for vortices in a perfect fluid. A magnetic field line would therefore be a vortex of ether. Finally, let's turn to the strong interaction within an atomic nucleus. Here again, physics has difficulty in explaining simply how two charged particles, such as protons, can remain stuck in a nucleus, despite a gigantic repulsive force. Let's first calculate the electrostatic repulsion force between two protons of the nucleus, supposed to be joined. The radius of the proton is 0.87 femtometer. The charge is 1.6 10 power minus 19 coulomb, and the distance between centers to radius. This gives us a repulsive force of 76 Newton, or about 8 kilograms. Wikipedia tells us that the strong interaction is 100 times higher than the electrostatic repulsion force, so about 7,600 Newton. But it is only exerted at a distance of 1 femtometer, thus when the particles are in contact. Let us now suppose that these two protons are in a pressure field, and that their contact surface is about 1/4 of a radius, where the external ether pressure can no longer be exerted. What is the pressure needed to have this force of 7,600 Newton for a contact surface with a radius of 0.22 femtometer. It takes a pressure of 5 × 10⁻34 Newton per square meter, or an energy density of 5⁻34 joules per cubic meter, because an energy density and a pressure are the same thing. Okay, this is a huge number, but still far from the 0-point energy density of quantum physics. We can also calculate the energy density of the proton by the formula E equals mc², related to its volume. Well, hang on, we find there again 5 × 10⁻34 joules per cubic meter. It seems crazy, but when you think about it, it's quite logical. If the vacuum was really empty, we can wonder how the particle would do not to explode. So, everything leads us to believe that the ether pressure difference between the outside of a proton and the inside of a proton is about 5 × 10⁻34 joules per cubic meter, and that a strong interaction is only a confirmation of the existence of the ether. You must be wondering if this pressure really exists. Why then we don't feel it? Well, it's like air. Our body is permanently under a pressure of 15,000 kilograms, but we don't feel anything. Well, that's it for today. See you soon, and don't hesitate to watch the other videos on my channel in the meantime. Bye bye!